Okay, Bismillah ar-Rahman ar-Rahim. We'll continue. Just I tried to put this slide, which I put everything about 9.2 in one slide. So as I said before, because now we'll do more examples. Examples and examples. Okay, so for the infinite series, what I will do, I'll find the nth partial sum, the nth partial sum. Then I'll find the sequence of this partial sum. If the sequence converges to a value S, then the series converge, and the limit is the sum. So we have S, it is the limit to the partial sum as in goes to infinity. If it is converged, with the case converges, and that will be the summation of these an terms. If this is in diverge, then it diverges. As I said, we have mainly two cases, telescopic series, where there is cancellation like this. I have the remaining is B1 minus Bn plus 1. So I have, this is my sequence of partial sum, or my nth, this is Sn. So S1 is the, S1, S2 until Sn, these are the sequence of partial sum. I check the limit of this. If it is a value, then we say the sequence converges. I have the geometric series. This is my Sn in this case. So the control where with Rn. If the absolute value of R less than 1, then Rn goes to 0, so you have A over 1 minus R. If it is greater than or equal to 1, then that will diverge. This is the geometric series. The last one, test for divergence. If the limit of the n term does not exist, or the limit of the n term, which is An, I mean, not equal to 0, then the series diverge. Okay, let me do more examples. This is 2 over 4 n square minus 1. For sure, this is not telescoping. If I check An, 2 over 4 n square minus 1, so it will be the limit of An, as in goes to infinity. Very clear, it's 0. No conclusion. I cannot conclude anything. No conclusion. So what is the remaining? If we say find the sum, the remaining for me just as telescoping. It is telescoping, yes, but I need to do partial fraction in this case. 2 for n square minus 1. It's 2 over 2n minus 1, 2n plus 1. And that will be A over 2n minus 1 plus B over 2n plus 1. Okay. Now, if I cover this, substitute half, you will get 2 over 2, which is 1. If I cover this, substitute minus half, you will get minus 1. You can check 2n plus 1 minus 2n plus 1. That will be 2 over the product, which is 4n square minus 1. Okay. So the series, our series, which is 2 over 4n square minus 1, it will be the same as this one, which is 1 over 2n minus 1 minus 1 over 2n plus 1. Yeah, it seems to be now telescopic. So what is Sn will be A1 plus A2 plus A3 plus An minus 1 plus An. Let me see what will happen. A1, substitute 1, you have what? 1 over 2 minus 1, that will be 1 over 1 minus A equal 1, I have 1 over 3 plus. Now A equal 2, 1 over 4 minus 1, which is 1 over 3 minus 2, which is minus 1 over 5. Yeah, now it seems to me it's very clear telescopic. A equal 3, 1 over 5 minus 1 over 7 plus. Now if I substitute An minus 1, I have what? 1 over 2 n minus 2 minus 1, 1 over 2 minus 3 minus 1 over 2n plus 1 plus, what is An? 1 over 2n minus 1. No, sorry. N minus 1. So I put n minus 1. That give me what? 2n minus 2 plus 1. That will give me 1 over 2n minus 1. Sorry. And this is plus 1 over 2n plus 1. Okay. So very clear to me, this cancelled, this cancelled, this also cancelled here, and this one will be cancelled with this one, and this one cancelled. So Sn will be what? Will be 1 minus plus, not minus, plus 1 over, it will not make a difference. So it will be S. S will be the limit of Sn as n goes to infinity. Don't forget, I have it here. Okay. So that give me what? Yeah, this limit is very clear. This is 1 over infinity 0. That will be 1. So the series, which is this series, converges. Not only that, and its sum is 1. So this is what we have here. S will be the sum of the series. Okay. Now let me go to this question. Sometimes he will give me Sn. He said, this is your Sn. How he did it, I don't know. It's not my business. Then we need to find the sum of the series. So it will be the sum. What will be S? S, I have Sn. He gave me Sn. Through which method? It's up to him. But he gave me Sn only. So that will be the limit of Sn as n goes to infinity. I need to do the limit. That will be 2n over 3n plus 5. This limit is very clear, is what? Have same degree. Since I'm doing the limit as n goes to infinity, so it will be 2 over 3. So that means the series an converges and its sum is 2 over 3. That I get it only from Sn, because this is what I need to discuss the convergence of the series. Show that the series converge and find its sum. Okay. Yeah, it seems to be telescoping, but first I need to do the partial fraction things. That will be a over n, b over n plus 1. Cover this, I'm getting 1. Cover this, I'm getting minus 1. So I have n plus 1 minus n, which is 1 over n times n plus 1. Okay, so this series, 1 over n plus 1, would be the series of what? 1 over n minus 1 over n plus 1. Okay, so it will be Sn, it will be A1. At 1, it will be 1 minus half A2 at n equal to half minus 1 over 3. Yeah, don't forget Sn. Usually I write it this way. Since there is only one term. Okay. 1 over 3 minus 1 over 4 plus 1 over n minus 1. Sorry. Minus 1 over n. Yeah, by the way, this is minus. Sorry. Yeah, this should be minus. That will not make a difference in the conclusion. But just, yeah, this should be minus. Yeah. Plus 1 over n minus 1 over n plus 1. So now I have this, cancel this, this cancel this will be cancelled somehow, and this one will cancel, this cancel this. So I have Sn 1 minus 1 over n plus 1. So it will be S, will be the limit of Sn as n goes to infinity. And that will be the limit as n goes to infinity, 1 minus 1 over n plus 1. And that's equal to 1. So the series converges, not only converges, and its sum is 1. Len n over n plus 1. What is this? Len n over n plus 1. For sure, this is not geometric. If I find the limit, let me check the limit. An is len n over n plus 1. So it will be the limit of an as n goes to infinity. It will be limit as n goes to infinity of len of this. Since len is a continuous function, I can take the limit inside. I'm getting nothing out of that, but just to check, that will be limit same degree. That will be len 1, which is 0. So I have no conclusion. So this is give me nothing. So the only things in my mind is telescoping. Is that telescoping? Okay. Let me check. N equal 1 to infinity. Len n over n plus 1. Yeah, we'll use this. That will be summation n1 to infinity. Len of n minus len of n plus 1. I know the rule of this len. Len x over y is len x minus len y. Yeah, now it's clear. So I have S1 or Sn, I mean, we do Sn right away, which is A1 plus A2 plus A3 plus An minus 1 plus An. That give me what? Len 1 minus len 2 plus len 2 minus len 3. Okay. Yeah, you know what? Let me do it in the second line. That will be len 1 minus len 2 minus len 2 minus len 3 plus, not minus, plus len 3 minus len 4 plus len n minus 1 minus len n plus len n minus len n plus 1. Good. That will be minus. Very clear telescoping. So this is cancelled. This is cancelled. This one cancelled. This one cancelled. This one cancelled. So I have Sn len 1 0. I have its minus len n plus 1. Yeah, let me write something here. This is we say telescoping, huh? Yeah. Since we have this, I have telescoping. Okay. And the same thing here. We should write telescopic. No, this is not. This is telescopic. We say telescopic. And so on. Okay. Yeah, just to be sure. Okay. So what I need to find S, which is the limit of Sn as n goes to infinity. That will be what? Infinity plus 1 is infinity. Then infinity is infinity. That is minus infinity. So the series, what will happen to this case? Diverges. It will not converge. Okay. Let me do more problems. Okay. Now, for me, it seems this is geometric. As I said, the geometric, either you will do this, the formula. This is a over 1 minus r less than 1. What is diverge? Let me check. Summation n equal 1, not 0, n equal 1, ar n minus 1, n equal 1. Yeah. So it is a actually plus ar squared. So it's starting from 1. Okay. Or I can do this, which is a is the first term and r is the ratio. Okay. Open this. You have what? 3 2 to the power 0, 3 over 1. Yeah, because starting from 0, plus 3 over what? 2 plus 3 over 4 plus 3 over 8 plus. So A is the first step, A equals 3. What about R? R is the ratio. So I need to check two terms at least. 3 over 2 over 3. That will be what? Half. Also check R 3 over 4 times 2 over 3, which is half, and so on. So for sure it's what? Can check more. So R equal half. So I have A equals 3 and R equal half. That's the most important. Absolute value of R, half, less than 1. Right away, the series converges. I know first it's hysteroscopic. Very clear to me, hysteroscopic. Okay. So it will be S A over 1 is not hysteroscopic, geometric, I mean, sorry. It's geometric series. Very clear geometric series. Okay. S equal A over 1 minus R, that will be 3 over 1 minus half. That will be what? 3 over half, and that will be 6. Yeah. You can find A and R using this procedure. How we can do this? Now if we want to use the other way. Yeah. I want the summation to start from 1 to make it in the same format. So I have summation n equals 0 to infinity, 3 over 2 to the power n. That is 3 plus summation n equal 1 to infinity, 3 half to the power n. Is it in the first format? Not yet. I want n minus 1. So that will be 3 plus summation n equal 1 to infinity, 3 half to the power n minus 1. So that is 3 plus summation n equal 1 to infinity, 3 over 2 half to the power n minus 1. Now we need to be careful. I'll do this sum aside, and then I add 3 to it. 3 is just a number. So for this, I have what? A is 3 over 2, and R equal half, in the same format. So that will be 3 plus the sum of this, which is A, 3 over 2, over 1 minus half. That will be 3. This is 3 over 2 over half. That's 3 plus 3 equals 6, which is the same answer. Yeah, but you need to be careful about the calculation. Okay. Yeah, 6. The answer is 6. Okay. This one. Yeah, very clear to me. This is geometric series. I have geometric. Yeah. If I want to write it in this format, let me open it up. That will be 1 plus 3 over 2 plus 3 over 2 squared, blah, blah, blah. Oops. Plus, plus, plus. Okay. So I have A equal 1 and R 3 over 2 over 1, which is 3 over 2. R 3 over 2 square over 3 over 2. That's also 3 over 2, and so on. So I have A equal 1 and R equal 3 over 2. Be careful. But absolute value of R, which is 3 over 2, this is greater than or equal to 1. So the series diverges without doing anything. Okay. Use geometric series to write this. 0.08 as the ratio of two integers. How to do this? 0.08 repeated. That is what? 0.08, 08, 08, 08, and so on. Which I can write it? 8 over 100 plus 8 over 10,000. Yeah, because this is 8 out of 100. Now this one, yeah, plus 8 over 1,000, 10,000, plus 8 over 10 to the power 6, plus 8 over 10 to the power 8, plus. Yeah. Actually, you can write this as 0.08 plus 0.0008 plus 0.0008 and so on, which is this one. Okay. Now, if you look at this one is what? This one is geometric series. Not only that, I have A is 8 over 100, and R is what? 8 or 10,000 times the reciprocal of this, divided all times the reciprocal, that will be cancelled. This cancelled, so I have 1 over 100. And check also R, another one, 8 over 10 to the power 6 times 10 to the power 4 over 8, which give me 1 over 100 still. And the same thing for the rest. So I have A is 8 over 100, and R is 1 over 100. R, absolute value of R, 1 over 100, less than 1. So the series converges. And its sum is what? A over 1 minus R. What is A? 8 over 100. What is R? 1 over 100. That will be 8 over 100. This is what? 100 minus 1, 99 over 100. That gives me 8 over 99. And that is the answer. Okay. Determine whether the series is convergent or divergent. If it's convergent, find its sum. Okay. So now, I think they do this. Yeah, we just open it up. So that will be what? At n equals 0, that will be 5. At n equal 1, yeah, very clear. This is geometric. Huh? Geometric. Okay, at n equal 1, that will be 5 minus 3 over 2. At n equal 2, that will be 5 minus 3 over 2 square, and so on. Okay, so A equal 5, and R will be what? 5 minus 3 over 2 square over 5 minus 3 over 2. And that will be what? That will be minus 3 over 2. So notice R, absolute value of R, absolute value minus 3 over 2, it will be 3 over 2 greater than 1. So the series diverges. Determine whether the series is convergent or divergent. If it is convergent, find its sum. Okay. Yeah, it's not true scoping. Okay. Can I write it as an n term? An as an n term. Yeah. Let me check. Let me check R. R will be what? 6 over 8. That will be 3 over 4. Yeah. R2 will be 9 over 2 over 6, which is 9 over 2 times 1 over 6. That will be what? This is 2 over 3, and this is 3. 3 over 4. R2, just to be sure. 27 over 8 times 2 over 9. That'll give me 1. This is 3. This is 1. This is 4. 3/4. Done. So I have A is 8 and R equal 3/4. So it's geometric series. I need to find AN. Or if I need to find AN, it's A R to the power N to the power N minus. Okay, we can write it in the way you like. But this is A and this is R. So absolute value of R, which is 3/4 less than 1. So the series converges. Not only that, and its sum is A over 1 minus R. What is A? A is 8. 1 minus 3/4. That will be 8. 1/4. So the answer is 32. So this is equal to 32. Okay. Yeah. Is there a difference between these two series? Both of them are geometric, very clear. Geometric series. Okay. So, yeah, let me do this first. Or let me do this first since it's the beginning. If you notice, this is what? Summation n equal 4 to infinity. Look, the difference here. Half to the power n. So this is what? If you open it, it will be half to the power 4, which is 1/16 plus, let me write it half to the power 4 better. Half to the power 4. Then I have half to the power 5, half to the power 6 plus blah, blah, blah. So what is A? A is half to the power 4, and R very clear, it's half. So it will be S. S will be A over 1 minus R, which is 1/16 over 1 minus half. So it will be 1/16 times 2, which is 1/8, which is this one. Okay. Now what about the other one? Half to the power n. That if you open it, it will be 1 plus half to the power 1 plus half to the power 2 plus blah, blah, blah. Okay, so what is A? A will be 1. And what is R? R will be half. Very clear, R equal half. So it will be S. It's 1/1 minus half, and that is 2, which is this one. Okay. What is the point? The point is this one, summation, or this one, let me say this one. Better to start with this one. N equals 0 to infinity, half to the power n. I can write it, if I know this, I can write it as what? Open it up, half to the power 0, plus half to the power 1, plus half to the power 2, plus half to the power 3, plus this summation, 4 to infinity, half to the power n. Yes, 0, 1, 2, and then this. If I know this is equal to 1/8, because this one, so it will happen. So this one is 0, 1, I mean, not 0. 1 plus half plus 1/4 plus 1/8 plus this. This one is what? 1/8. So if we do the calculation, that will be 1 plus, I can write it over 8, 4 plus 2 plus 1 plus 1. So it's 1 plus 8/8, which is 2, which is the same answer. Yeah, so you can deal out. I mean, if I know this, no need to do all of these calculation again. I can do it this way. This is the point. Find the sum of this geometric series. It's always geometric series, and that will make it easier for me. A equal 5. A equal 5. And what is R? Minus 10 over 3 over 5. That will be minus 10 over 3 times 1 over 5. 1 minus 2, which is minus 2 over 3. What is R? Just check. 20 over 9 times minus 3 over 10. Oops. This is 2. This is 1. This is 3. Minus 2 over 3. Or minus 40 over 27, to be sure. Or you can do it the, yeah, this is minus 2. This is 1. This is 1. This is 3 minus 2 over 3. So R equal to over 3. So A minus 2 over 3. One over equal R equal 5, and R is minus 2 over 3. Absolute value of R is 2 over 3, less than 1. So we have the series converges, and its sum is S, which is A5 over 1 minus 2 over 3. Be careful here. That will be 5. 5 over what? 1 plus 2 over 3. That will be 5 over 3, which is 5 times 3 over 5, which is 3. So that is the sum. And that is the answer. Yes, correct. Okay. This one, 2 to the power 2n times 3 to the power 1 minus n. What is this? Yeah, let me try to rewrite it first in a form, easy form. I have what? 2 to the power 2 all to the power n 3 times 3 times 3 to the power minus n. Yeah. Now, if we write it this way, that will be summation n equal 1 to infinity. 3 times 4 to the power n times 3 to the power minus n, and that will be 3 times 4 over 3 to the power n. And now it's ready to be as a geometric series. If you remember the form, this is the form. So n equal 1, I have A, I have R. To the power n minus 1, I can do this. And to be in the same format, so I have summation n equal 1 to infinity, 3, 4 over 3 times 4 over 3 to the power n minus 1. To make in the same format, so that will be summation n equal 1 to infinity, 4 over 3 to the power n minus 1. So it's now completely in the same format. Or you can, very clear for me, R is what? 4 over 3. That implies absolute value of R, 4 over 3 greater than 1. So the series diverges. I don't need to do all of this calculation. Find the sum of this series, x to the power n, where absolute value of x less than 1. I can do the same. Open it up. That will be 1 plus x squared plus x cubed, blah, blah, blah. So what is A equal 1, and R, x over 1, x squared over x cubed over x squared. All of these are equal to x. All of this is equal to x. So R equal x, and R equal x, so absolute value of R, which is absolute value of x less than 1. So the series converges, and its sum is what? S A over 1 minus R. What is A? A is 1, R is x, and that will be the answer. So this summation, actually we'll use it later, it's 1 over 1 minus x. Write this number, as a ratio of integers. Mhm. Be careful here. Yeah. Let me do it later. I'll do it later. Just let me go with this interim test for divergence. I will do that slide later. Okay. Now I have 2 to the power n. What will happen? My an is 2 to the power n. So it is the limit of an as n goes to infinity will be the limit as n goes to infinity of 2 to the power n. 2 to the power infinity is infinity. Right away, the series is not equal to 0. So the series diverges. What about this one? An is n factorial over 2 n factorial plus 1. I want to find the limit of this. Limit n goes to infinity of an. That will be limit n goes to infinity n factorial 2 n factorial plus 1. How to find this limit? Easily, I can divide by n factorial. If we divide by n factorial, n factorial, n factorial, that will be 1 over 2 plus 1 over n factorial. That give me what? Yeah, let me do it in details. Yeah, that will be n factorial over n factorial over 2 n factorial plus 1 over n factorial. That will be limit n goes to infinity 1 over 2 plus 1 over n factorial. If n goes to infinity, n factorial goes to infinity, so this goes to 0, that will be half, not equal to 0. So right away, this series diverges. Another one, this one, what is an? Minus 1 to the power n. What is the limit of an as n goes to infinity? It will be the limit minus 1 to the power n as n goes. I know this limit does not exist because it oscillates between 1 and minus 1. Right away, the series diverges. It will not converge to a value. 1 over n. 1 over n is a special case. Yeah, here the limit as n goes to infinity of 1 over n is equal to 0 if I take an 1 over n. No conclusion. Not only that, we'll prove later that this series actually diverges. They call it harmonic series. They call it harmonic series later. The limit goes to 0, no conclusion. We cannot conclude anything. Okay, let me do this one. An equal n here. So it is the limit of an as n goes to infinity. It will be the limit of n as n goes to infinity, and that is infinity. Right away, the series diverges. The idea of this video is I wanted to show you different example of all these 3 cases: telescoping, geometric, and test for divergence. This one, an is what? Minus n over 3 n plus 1. What will be the limit of an as n goes to infinity? It will be the limit as n goes to infinity of minus n over 3 n plus 1. Same degree, minus 1 over 3, not equal to 0. Right away, the series diverges. If the limit of the n term not equal to 0, right away the series is what? Diverges. Okay. This one, an is what? Tan inverse of n. What is the limit of an as n goes to infinity? It will be the limit as n goes to infinity of tan inverse of n. I know tan inverse of infinity is what? Pi over 2, not equal to 0. Right away, this series diverges. This one we did before. We did before. Yeah, this one. And we prove its diverges as a telescoping, yeah. Diverges. No need to do it again. I know I have a space here. Okay. This one, an will be what? N squared. Notice these, all the examples diverges. Huh? So just to show you the n term test for divergence, it will be the limit as n goes to infinity, n squared over 5n squared plus 4. And that is what? Same degree, 1 over 5, not equal to 0 right away. This series to what? Diverges. These 4 examples, and then I will stop this video. Okay, n squared. What is an? By the way, all of them diverges. An is n squared. What is the limit as n goes to infinity of an? Will be the limit as n goes to infinity of n squared, which is infinity. So the series diverges. This one, yeah, very clear. An, n plus 1 over n. What will be the limit of an as n goes to infinity? That will be the limit as n goes to infinity, n plus 1 over n, which is 1, not equal to 0. Right away, the series diverges. This one, n minus 1 to the power n plus 1. So the limit does not exist because it will oscillates. So the series diverges. The last one, an minus n over 2n plus 5. I think we did it before. No problem. So the limit as n goes to infinity of an will be the limit as n goes to infinity minus n over 2n plus 5, which is minus half, not equal to 0. So this series diverges. Yeah. Then I'll do more examples in the next videos. Okay, let me stop here. Just we did more examples in different interscoping in geometric and in term of for divergence. So let me stop the recording. Yeah. Thank you.